kids. All right. You should have been doing a little bit of stuff about reflection. And you might ask, well, why is reflection so important? Well, reflection is essentially what allows us to see just about anything. So if you were to, look at this pencil, for example, the reason you can see the pencil is that light is bouncing off this pencil. And, well, if you were standing here, it's going to your eye. In this case, the light is bouncing off the pencil and going into the camera. But that's how you can see it. So things are super duper important because reflection is super important. When light bounces off something, if it goes back to your eye, that allows you to see things. And that's how we see almost everything, okay, is that the light bounces off it and goes to your eye. So you should have, first of all, understood that when light bounces, the angle that it comes in at is equal to the angle that it bounces off at. So the law of reflection states that the angle of incidence equals the angle of reflection. Okay, and you might ask, well, when is that true? Well, that is true anytime light bounces, okay? It is not called the sometimes of reflection. It is called the law of reflection. Why is it called the law of reflection? Because anytime light bounces, this is true. The incoming incidence is just a fancy way of saying the incoming and reflection. So in physics, we're going to have to be able to do things words, math, pictures. So here's the words, here's the math. The angle of incidence equals the angle of reflection. And then here's the picture. So let's say you have a mirror here. Most of the time when we're drawing mirrors, we put little slash marks to represent the back of the mirror. And I have light that is coming in like that. Okay. Well, that light is going to bounce off, okay, like that, duh, okay, but this angle of incidence and this angle of reflection is always measured from this point here. This is called the normal line. Now, if you remember from physics class you took previously, you should have talked about normal force. The normal force was perpendicular to the surface, okay? The normal line is perpendicular to the surface. You can see, hey, look, there's a right angle there, okay? Why do we draw it dotted? Because if you look at a mirror, there's not some thing coming out of the mirror at you. It's just something that we measure from. So this equals this. Just remember, measure from the normal line. So if I wanted to label theta I, the incident angle, that's theta I. If I wanted to label theta R, the reflected angle, that's theta R. Okay? So it's super duper important. This is always true. Well, let's say, for example, we have a mirror and you have a light ray that comes straight down this way. Well, in that case, what's the angle of incidence? Well, you'd have to draw a normal line. How would I draw the normal line? Well, it would be right on top of that. So then what's the angle of incidence? It's 0. What's the angle of reflection? 0, which is why that light ray would bounce then straight back off. So it would go straight down and bounce straight back off. Okay? That's the law of reflection, the basics of it anyway. All right? So hopefully that makes sense. Bye, kids. Actually, you know what? Before I go, we're going to practice using a protractor because, you know what? Some of you are not so great at drawing, at doing this. So let's make sure you have your protractor, and I'll just teach you guys Protractor 101 on how to use a protractor. So we're going to draw a mirror. So using your protractor. So our mirror doesn't have to be perfectly horizontal. So there's our mirror. Okay. We're going to draw it flat. Okay. We're going to say the angle of incidence equals 20 degrees. Okay, so then I have to draw a normal line. Now you'll notice, do you see how I am lining the 90 up here? and then I'm going to draw my normal line. So, hey, look, that actually is perfectly perpendicular. Now, if I want to measure 20 degrees, remember, I measure from the normal line, okay? I would like you to pause it and see if you can draw it. So pause it and try it. Did you actually pause it? Did ya? Now, my guess is some of you laid your protractor down like this. If you did that and you measured 20 here, no, because that would be measuring from the mirror's surface. I want to measure from the normal line. So you should put your protractor like that. Again, do you see how this little spot here is here to here? So then I'm going to put a dot at 20 degrees, and I am going to draw in my incident ray, where this would be theta I, which is 20 degrees. Then if I wanted to draw theta R, and this always cracks me up because sometimes this will be drawn for you, and then I'll have some students that will draw this, and they'll get something that looks like this, where it's like, I'm going to draw this lightly because it's going to be terrible. They go like this, and they're just like, oh, that's fine. And I'm like, look, does that look like it's equal? Does that look even possible? And they're like, oh, well, I don't know. That's what I got. No, use your brain, people. Think, think, think. Okay? So measure from the normal line. So here's my 20 degrees there. And then if I draw it in, that would be my 20 degrees. Angle of incidence equals angle of reflection. All right, now, bye, kids.